Hey everyone, welcome back to the networking series. Today we're diving into the different ways that networks can be arranged, also known as network topologies. The topology of a network determines how devices are connected and how they communicate with each other, affecting performance, scalability, and reliability. In this video, we'll cover the main types of network topologies, their advantages, disadvantages, and when they're best used. Let's get started. First, what exactly is a network topology? Well, in simple terms, a network topology is the arrangement of various elements like computers, servers, and devices within a network. It can describe both the physical layout, which refers to how devices are physically connected, and the logical layout, which defines how the data flows within the network. Let's start with one of the simplest topologies, the bus topology. In a bus topology, all devices are connected to a single central cable called the bus. When one device wants to communicate with another, it sends data along the bus, and the data travels to all devices until it reaches the destination. The bus topology is easy to set up and requires minimal cabling, making it cost-effective for small networks. However, it has some major downsides. If the central cable fails, the entire network goes down. Additionally, as more devices are added, the network can become very congested, leading to slower performance. Next, we have the star topology. In a star topology, all devices are connected to a central hub or switch. The hub acts like a traffic controller, directing traffic between devices. This topology is a common one in home networks and small offices because it's easy to set up and easy to troubleshoot. One of the main advantages of the star topology is that if one device fails, the rest of the network remains operational. The central hub or switch can also help manage network traffic and reduce congestion. However, if the hub itself fails, it can take down the entire network. Moving on, we have the ring topology. In a ring topology, each device is connected to two other devices, forming a closed loop. Data travels in one direction around the ring until it reaches the intended device. The ring topology has some advantages such as balanced traffic flow and predictable data transfer. However, if any single device or connection in that ring fails, it can disrupt the entire network. To address this, some rings use a dual ring topology, where data can travel in both directions to provide redundancy. Next up is the mesh topology, which is one of the most robust and reliable topologies. In a mesh topology, every device is connected to every other device. This provides multiple paths for data to travel, which makes the network highly fault tolerant. The mesh topology is ideal for critical networks where reliability is a priority, such as in data centers or large enterprise networks. The downside is that it requires a lot of cabling and configuration, making it more expensive and more complex to set up. There's also a variation called the partial mesh topology, where only some devices are fully connected, while others are connected to just a few devices. This helps reduce the cost while still providing some redundancy. Another common topology is the tree topology, which combines characteristics of the star and bus topology. In a tree topology, groups of devices are connected in a star configuration, with each group connected to a central bus. This hierarchical structure resembles a tree with branches representing different segments of the network. The tree topology is scalable and easy to manage, especially for larger networks where different segments need to be organized. However, if the main bus or a key segment fails, it can affect the entire network. Lastly, let's talk about the hybrid topology, which is a combination of two or more different topologies. For example, a network might use a star topology in one section and a mesh topology in another section. Hybrid topologies allow network designers to take advantage of the strengths of different topologies while minimizing their weaknesses. Hybrid topologies are flexible and can be customized to meet the specific needs of a network. However, they can also be more complex to design and manage due to the mixture of different topologies. You need a lot of documentation in those cases. So, we've covered several types of networking topologies: bus, star, ring, mesh, tree, and hybrid. Each has its own advantages and disadvantages, depending on the size, purpose, and requirements of your network. The choice of topology can impact not just the performance, but also the scalability and fault tolerance of a network. Let's quickly recap. A bus topology is simple and cost effective, but can be prone to network failure if that main cable is damaged. The star topology is easy to troubleshoot, but the central hub can be a single point of failure. The ring topology provides predictable data transfer, but it's vulnerable to a single failure. The mesh topology offers excellent fault tolerance, but at a very high cost. The tree topology organizes devices in a hierarchical structure, making it scalable, while the hybrid topology combines different topologies for greater flexibility. In our next video, we'll dive into network cabling and the different types of cables used to connect the devices. We'll cover the differences between copper and fiber optic cables, their advantages, their disadvantages, and when to use each type. Make sure you subscribe so you don't miss it. Thank you all for watching. I really do mean that. Don't forget to like, comment, and subscribe, and I'll see you all in the next video.